and today we're going to be looking at a nice property of a function that's going to lead us towards a general theorem later. So let's take f from Rd to Rd such that over a specific ball around 0 with radius r, there exists some r greater than 0 such that in the ball of radius r around the origin, matrix. Alright, so now here's what we're going to figure out. I'm going to take some ball of radius r over 4 around 0 within that ball of radius r. And now I'm going to take a scalar valued function, g of x is equal to the norm of f of x minus, I'm going to choose some point y inside this ball, so f of x minus y squared. So, can we find a minimal value for g of x? Well, what can we do here? So given that our x is in that ball of radius r around 0, and actually, let's assume the norm of x is equal to r. So then, what can we do? Well, as we know, by the triangle inequality, this is always greater than or equal to this. Now we know what? Well, we know that f of x is going to be something special, right? So over this interval, or this ball, by what we know, and I'll prove this in the next lecture, this is actually an injective function. So what does that tell us? Well, that means that this guy right here, f of x, it's going to be, the norm of f of x is going to be less than or equal to r. And y's norm is going to be, well, less than or equal to r over 4. Or can we say this? Well, actually, since the norm of x is equal to r, what can we say about the norm of f of x? Well, we already know that the inverse function exists. We already know all of this. So it should be plausible to say that the norm of f of x is equal to r. But that would imply that r minus something that's less than or equal to r over 4 is 3 over 4r, which implies that g of x has to be greater than or equal to the square of that, which is 9 over 16r squared. Thanks.